Welcome to Longevity Industries' presentation of the Destiny of Manufacturing podcast, brought to you today by the Precision Metal Forming Association and the PMA's Educational Foundation. We're glad to have them as a sponsor. And today I have a distinct pleasure of having Will Healy here from Balluff, where he is the marketing management director, And we're happy to have him here because his insight is incredible into things like the Internet of Things, where we're going with sensors and what our future will look like, because as many of you may have heard, sensors are where it's at. Will, thank you for being here, sir.
Thank you, Dean. I really appreciate you having me today. Definitely excited to talk about it. I mean, I think smart manufacturing, Internet of Things, all that kind of stuff is something that gets me excited. So it's a neat topic to be on your podcast today.
Thank you so much for being here and taking time out of your busy schedule to do that. So tell the audience a little bit about yourself and your background.
Yeah, for sure. I graduated from Purdue University with a mechanical engineering degree more than a decade ago. Wow, time goes by quickly. I graduated from Purdue with a mechanical engineering degree. I came to a company, Balluff. We make sensors and automation, networking products, RFID. We make automation products that enable people to automate their facilities and to do things like poka-yokes and error proofing and traceability. So I started in the sales trainee group working with a guy named Dave Bird, and really learning about metals and metal fabricating from day one of my education. So visiting customers, learning about their problems, and helping them find sensors and solutions to improve it. And over the years, I was the cable product manager and then the networking product manager as our networking products expanded. And, as smart sensors became more of a topic, I was a product manager for a technology called IO-Link, which is an open standard for connecting smart devices together in the industrial Internet of Things. And so now I'm really focused on big picture strategy and where we're going, and specifically kind of being an expert in the topic of smart manufacturing. So.
Yeah, and for those of you who may be unaware or have been under a rock for a while, Will has certainly is a well-respected individual, not only across the Precision Metal Forming Association, but across the industry as a whole, and we're very happy to have him here. What I'd like to hear is, tell me a little bit about why you got into manufacturing. What excited you about getting into manufacturing?
Yeah, manufacturing is, honestly, it's cool. Actually, the fourth happiest job in America is manufacturing automation engineer. Fourth happiest job in America. Isn't that crazy? It's a USA Today poll that they put together. And I think manufacturing is so exciting because we get to work with machines that make stuff. I mean, if anybody's ever gone to IKEA and bought a piece of furniture, you put that thing together, you swear at it some. But when you get all done and you're like, I built that, that's really an awesome feeling. And so just in general, working in manufacturing and especially working with automation in manufacturing, it's just exciting because you're making and working with stuff that makes stuff, not just it's cool.
Right.
I've seen, Dean, how a tree turns into a 2x4, how metal comes in one side of a plant and turns into aluminum can for beer at the other end. Some really cool things that we do, and it's not our grandfather's manufacturing anymore. It's really cutting edge technology, and it's just neat.
Absolutely, and I think shows like How It's Made have changed people's view of manufacturing also. Those kinds of shows, because people, I think, can identify with it because they see how something is made and they're like, that is really cool. And it's gotten people interested in things like STEM curriculums and gotten them interested in some of the programming things like Python and robotics. And 3D printing has gone crazy. Not just for manufacturing, but even for home use. I think a lot of people just find a neat way to build another widget kind of thing. And let me
I'll
ask
tell you, I know the exact moment I fell in love with manufacturing. You want to hear it?
Yes, please.
So it was in my first year. I was visiting customers, and I went to a plant that makes tissues. And you know how in the box, when you pull a tissue out and another one comes out behind it?
Yep.
You know how they do that?
How they interweave them, you mean?
Like if it's a 100-count box of tissues, they spin 100 rolls of paper, of tissue, simultaneously and actually like cut it off, move it down a conveyor belt, push the next tissue in, fold it over, cut it off, push it down, fold it over. They simultaneously spin like 100 rolls of paper all at the same time, and out the end comes a stack of 100 tissues all wove together.
Wow.
It was the most incredible thing, and I was like, I want to be a part of whatever that is.
Sure, and it is interesting, and I've found when you go into a plant, you get an opportunity to see how something's done that can help you in other areas. I've gone through companies like the Bun Company, who obviously makes by their name, makes hamburger buns and different types of rolls for different food processing companies, but how they move the parts back and forth using air. I say parts, it's a roll, you know, but it's what they're making, and they use air. And I've referred many a company in stamping to that type of process using air for moving their parts.
Cool, even their metal parts.
Yes, you know, because a lot of times it's a very simple way to do it that you don't even think about. And I wouldn't have thought about if I not had the opportunity to go and tour a plant like that.
Yep.
So
yeah, that's cool.
It is. Let me ask you. Let's take a look at the destiny of manufacturing and look at 5 years ahead, where we're going. Where do you see some of things technology-wise changing? How do you see that process starting to take place?
Wow, loaded question. So when you think about the future of manufacturing, I mean, you could talk about all kinds of crazy, robots making robots kind of stuff. But if you're just talking about 5 years, 2022, I still see some dramatic changes in what's going on. I mean, one that I'm seeing a lot of right now is the implementation of tablets and mobile devices into the workspace. You know, a lot of facilities that you visit, Dean, I'm sure you've been to them where it's like, no mobile devices on the plant floor because of safety issues, right? They don't want people looking at Facebook and get hit by a fork truck because they're walking outside of the pedestrian aisle.
Right.
So balancing, when you look forward, I see a lot more mobile devices on the shop floor 5 years from now. I mean, line supervisors with a mobile device to be able to see what's going on their whole production line without looking at each operator as they're working. We have a customer who just got rid of all the HMIs on their floor and went to a SCADA system with all industrial PCs so that anywhere engineers, regardless of where they are, if they're at another plant or another facility, they've implemented now an engineer can connect with his tablet and he can support the production line from anywhere in the world right from his tablet, and he can look and see what's going on the equipment. And so right now that kind of seems like, well, we're never going to do that. But a lot of research data is showing that in 2 years, you're going to see about 4 times as many mobile devices on the production floor than there are today. And I expect that to just explode exponentially moving forward towards 5 years from now. And that's because of the things that the tablet device will do for us. Think about what if I saw an amazing technology in Mexico at a trade show. They had a small machine. The guy held up his tablet to the machine, and then he could click on a motor on the screen, looking at a picture or looking at the camera of the machine. So augmented reality through the tablet. He clicked on the motor came up, a 3D image of the motor came up, and instructions on how to deconstruct the motor. Undo bolt A first, then bolt D, then bolt B, then bolt E, then bolt C, then bolt F. I mean, like, it had the order, and it showed how to take it all apart. He wanted to see the manual. He clicked on a button, and boom, there was the manual right on the tablet for that motor on that machine. This is the kind of information that we're going to need for our maintenance crews Because looking 5 years in the future, we're going to have major skill set problems. So, when you look at where the skill sets are and the amount of retirements we're going to have and the few people entering into manufacturing at the moment, there's a pretty well-known skills gap that's going to occur. And so our maintenance techs are going to need more of that information at their fingertips. They're not going to be able to know that motor on that line. They're going to be supporting the whole plant, just a couple of guys maybe. And so having the information at their fingertips on the tablet to be able to do their job and have coaching in the moment to do the job, those kinds of things are going to be pretty important, I think.
Right. No, and I could certainly agree with that. As far as what you're talking about with using tablets for the purpose of maintenance and how obviously that's going to assist people that are trying to be better at their jobs, faster at them. They don't have to go climb down a ladder to go get copies of the electrical prints, be more responsive and be better at their jobs. What do you see that we're going to have to do as far as workforce development goes in order to use a lot of this technology?
Yeah, that's a really great point, Dean. I think we definitely have to have the expectation that we're going to need solid computer and executional IT style skills in our maintenance and our facilities people. So if they don't have that today, we're going to need to train those people on some of those skills, like working with Ethernet and understanding some of the functions there, understanding how security works are going to be trainings and information that people need to know. Jeff Immelt from GE, he said, one night you're going to fall asleep a hardware company and you're going to wake up a software company. And that's true not only for companies like Balluff, who's a vendor, but also for manufacturers. The data-driven decisions that you'll be able to generate, that's what's going to make you competitive in the marketplace, is your ability to use your data to your competitive advantage. So making sure that there are people that are in place to do that for you is going to be important.
Yeah, that's an area that I think a lot of companies struggle with. Is we've already gone through an iteration of being involved with big data. Big data goes, where do you think we're going to have to go in order to execute based on that data? And where do you think we're going to have to find ways to allow the equipment to actually make decisions for us?
Yeah, that's a really big question for sure. I think before you start thinking of big data, you start thinking of the cloud, you start thinking of all these kind of big pie in the sky ideas. I think the biggest thing is to figure out, what do we need to make our business better? What are our business goals? Do we have a zero scrap goal, or do we have a zero quality problem goal, or what are our corporate goals that we're trying to achieve? What data do we need from our equipment, and can we empower the operators with the data to make better decisions, or can we even empower the machines to make better decisions or adjustments on the fly? Those are the kinds of things that we have to decide first. Really, it's dangerous. I've sat through a lot of presentations, and it's dangerous to think, okay, we have a lot of data now. Let's start collecting it and putting it together in a database. If we build this giant data lake of all the data we have in our plant, it will get overwhelming and not useful very quickly. Think about a smart sensor. A smart sensor might just give you 1 byte of information, but it generates it every 20 milliseconds. So that's 50 bytes of data every second. That's 300 or 3,000 bytes of data every minute. You start doing the math on that, and you start having terabytes of data very quickly that you may or may not need. So
Right.
Knowing what your goals are first, and then choosing those pieces of information that you need and who needs them to execute the goals, that's really where to start, I think, for people. So.
Yeah. I think on the floor, a lot of people think that they want information, and information is just in and of itself going to give people the ability to make better decisions. But I don't know if that's really true, because we've been gathering data for a while, and I still see people making the same mistakes in their facilities. And I think we need to figure out, as you said, we need to figure out where we're going. We need to figure out what this information, how we're going to use it.
Yep.
And do you think that as far as sensors go, and how we've gotten to more smarter sensors, and we've put more sensors on equipment, the closing of the loops, both on the short-term closure where you're getting the information and you're acting on it at the machine level, then you're acting on it on a level of the information going out and being gathered in a database and acting upon it there. And then even bigger picture where you're starting to gather this information and look at it from a global standpoint. What do you think is the most important of those?
Yeah, I mean, global visibility is nice, and even plant level visibility probably will get funded. But knowing what's going on in your machine, I think, is probably going to give you your quickest return on investment. I mean, we're talking about 5 years in the future here. So if you want to be a highly competitive office 5 years in the future, probably making sure that you have good insight to your equipment, you know the OEE of every machine on your floor, that's a pretty strong place to start. If you have that information, you can get plant level views and you can get global corporate wide views. But if your machine's not generating any data, that's going to be a challenge. I mean, Dean, I asked the question. I presented a lot of conferences, especially in the metal forming space. I asked the question every presentation: who has a machine on their floor from before World War II? What percentage of people do you think raise their hand today?
I'd be shocked if it wasn't at least 50%.
Absolutely. It's usually around 50%. Some seminars, it's probably 40. Other seminars, it's closer to 60.
Yeah.
So, I mean, it's about half people have machines on their floor from before World War II. And I doubt that those are even Industry 3.0 machines, let alone Industry 4.0 machines.
Sure.
So looking at our equipment and enabling them and putting devices and sensing devices on it so we can at least can monitor the condition of good equipment. Because you're not going to go and bulldoze everything you got now and put in all smart factory, right?
Right.
That's not realistic. We don't have capital budgets for that. So making smart investments on the equipment we have, like putting, maybe you have a press that just has a stop and a go button.
Right.
Put a vibration monitor on it. Start trending the vibration data on that and look and see, is a die wearing, or are you having issues, with a cushion? There are different things that you can analyze by analyzing some data that you have.
Right. I think you hit on a key word there when we talk about where people need to be going with gathering data and information. We're historically been a go, no go kind of society where, as far as manufacturing goes, okay, is this good or is it not good? And we need to get away from thinking in that term. We need to start thinking in terms of, if it's getting bad, there's an acceptable level, and then there's some level of brand new level, there's a worn level, and then there's a failure level. And trending, I think, is an area that we need to get better at, not only gathering of the information, but we need to get better at what are those expectations. Do you see a direction where we're going in to make that happen?
Yeah, I mean, it's a good question. I have been seeing more metal formers putting more monitoring into their equipment. a lot of companies are offering different technologies that are allowing for monitoring. At FabTech, when I was there last year, there was whole aisles full of companies offering monitoring equipment, even like a bolt-on black box that has a couple of different sensors in it, like a temperature, humidity, vibration sensor, and then it reports data back to a central analysis hub. I think this all sounds scary, to be honest. Scary is not fair, but it sounds overwhelming, or we don't have the technical capability to do that. But the companies are making it easier for us to do this kind of stuff. I mean, I have no dog in the fight in the motor business, but ABB is marketing this smart sensor box that you bolt onto motors that they have, and then they have a centralized hub that you put in your plant, and it collects all the data from those smart motors, and then gives you predictive maintenance advice on what you need to do for those motors.
Yeah.
Or something like Fanuc. There's a really great Fortune magazine article with GM and Fanuc. They're the robot company. And I really recommend it. If you just Google Fortune magazine, GM, and Fanuc, it talks about how every robot is reporting back to a centralized system provided by Fanuc, and it's actually reporting the status of all the different servos. Is it going to the same place every time, or is it wearing on a motion? Is it taking longer to get to a certain location on each repetition? And it's tracking and trending all that data, and then providing a predictive maintenance schedule for the maintenance team. Because when we do preventative maintenance, we're only solving 18% of the possible failures.
Mm-hmm.
So more than 80% of our failures we're not catching by doing preventative maintenance. So being able to put in place devices like this that are doing predictive maintenance calculations for us, that's going to make us much better and much more effective at what we're doing.
Yeah, I think getting away from just the go, no-go type of sensor and on-off type of a sensor, and getting in the direction of analog sensing and trying to measure things. I mean, we do it in tonnage already, but I think that's a direction we need to take a better look at when it comes to analog sensing.
Well, and that's what's cool about smart sensors. I mentioned IO-Link at the very beginning. This is an open standard for connecting smart sensors to the industrial Internet of Things. And, a traditional photo eye that you would use maybe on part out on a stamping press, that just gives you one bit of information. It gives you on, off, did the part leave the press or not, right?
Right.
But we've got dye lube flying through there. We got all kinds of stuff going through there. And I'm sure nobody in your listening audience has ever had a nuisance stop from dye lube covering up a photo eye. Right? I mean, that happens. And so there are things that you can do with a smart sensor, like get a warning, hey, my lens is dirty. I'm still switching, but the next time you change jobs or when you take a break, someone needs to come over and wipe my lens off because I'm still working with something occluded.
Mm-hmm.
And so those kinds of little bits of data can remove nuisance stops and can make us much better at what we're doing.
Yeah. Maybe they'll go the direction of like NASCAR did, which was putting on those layers of peel-offable, basically covers for the windshield so that they could peel them off as they get covered with all kinds of garbage from the track. And maybe it'll be similar to that, where all the lenses come with peelable covers, in the long run.
It's actually not to promote Balluff, but I know we have like covers and lenses and protective caps specifically for those kinds of applications. So and I'm sure our competitors do as well.
Well, I apologize my ignorance for not knowing that.
Yeah, it's interesting. I mean, one other topic, thinking about 5 years, Dean, I'm sure you have more questions, but one I really think is interesting that I want to make sure I hit is augmented reality is I kind of mentioned on tablets, but even, Google Glass, everyone jokes about Google Glass, and they were an early adopter, and that didn't work out, but there's a lot of people entering the market with this kind of glass technology that really is starting to have value for people. The company Trump, if you know them,
yes.
Not our president, but the company that makes machining equipment, they make laser cutters and these kinds of things. They actually are using augmented reality to assist with maintenance of equipment. So you put on the glasses, and the tech guy in their office can see what you see, and he can talk you through a maintenance service yourself and get your machine running faster utilizing augmented reality and the guy seeing what you're seeing, and then he's actually able to circle stuff in your vision and tell you what to do in your vision or pull up a data sheet in your vision so you can see like the wiring diagram.
Yeah, I think that's a tremendous value. Yeah. Have you seen more people going in that direction?
The Trump's application is the first like real manufacturing application that I've seen applied and actually in use in the manufacturing sector. I've seen some people dabbling in it and talking about it. I've seen a couple of companies offering like machine maintenance visibility, so being able to look at a piece of equipment and see, is it running or not, kind of like a visual HMI.
Mm-hmm.
So I think one of the tricks about all these technologies, whether it's tablets or augmented reality or whatever you're doing, is we have safety policies in our facilities, and as we're adding new technology into our facilities, it might be violation of the safety policy of our facility. So we need to make sure that we have a process in our safety process to cover when we bring new technologies in. How do we adapt to it? We can't just say no to new technology. The technology is coming faster and faster, but we should have a process for how do we make sure it's controlled and done in an intelligent way. Because can you imagine if a guy had augmented reality glasses, he has all these displays for all the production status, and he's walking down an aisle, and he's not paying attention to where he's going because he's looking at all this production data in front of him, and he's not seeing where he's walking. And he trips on something, right? That could be a real problem in a plant. So making sure we have realistic expectations and working together with other departments to make sure we're doing the right things in our with the technology that we bring in over the next 5 years.
Absolutely. I think safety still needs to be a huge part of that, and we need to embrace the technology. We can't be intimidated. I think that's one of the areas that most people are challenged with now, is that a large portion of the engineers from 20, 30 years ago, even in the tool and die industries and some of the other ones that we really struggle with finding people to take their role as we move forward, it's harder to find people, and we have to look at technology to help us get there.
Yeah, I always like the idea that technology isn't really, at this point in manufacturing, technology isn't really eliminating jobs. It's making the worker an even more valuable resource in the organization. It's really enabling and empowering the worker to be an even more valuable asset to the organization. Because like I said at almost close to the beginning, we have a skills gap problem that's coming on the order of about 2 million jobs by the time frame you're talking about, 2022. So that's 2 million unfilled jobs in manufacturing. So we've got to embrace technology to make people more efficient, more effective at what they're doing.
Yeah. And the younger engineers, I mean, it's kind of like you have that millennial generation. That's in their wheelhouse. That's one of the things that they really excel at, is utilizing and embracing technology to help them work better, faster, and do a better job doing it. And that's one of the areas we really struggle with, I think, as a whole, is adopting that process. The other challenge, I think, from a metal forming industry versus a lot of the other industries is we probably are one of the worst when it comes to adopting technology. You know, you look at lasers. Lasers change technology almost every few years, and people buy new machines. As you mentioned earlier, how many people have equipment from, especially stamping presses, from World War II, or older? There's we do, when it comes to stamping, we're willing to sit it out and wait.
Yeah, absolutely. Let's see how this cell phone technology goes before we buy in.
This whole color television, this is just a fad.
Yeah, for sure.
It's a challenge we have. What? I got one more question, and we'll let you get out of here. When it comes to technology, if you had to pick one thing that you think is the most important to look at as we move forward over the next 5 years, what would it be?
Wow. I mean, when I think about the press shop and in the metalworking facility, really I think about we've got to work on press automation, which sounds not as exciting and cutting edge, futuristic as I would like it to be. But working every day with metal formers and talking to metal formers, there are people who are implementing automation in their press. But I'm even talking about sensors in dies, sensors used in press setup, and automating our press setup, automating to verify that we have the right metal for the right tool for the right job that we're running. Crashing a die because we set up the press wrong, we've got to figure out how to eliminate those kinds of very basic errors and issues. And they're more or less some of the simpler issues for us to fix and to rectify by implementing some basic die protection and by implementing some basic press setup technologies. And there are very good people who know a lot about implementing those kinds of technologies. And we've got to get our presses from World War II time frame and get those automated and have automated setup and automated functionality into that equipment. I think that really needs to be our focus over the next 5 years.
Sure. Well, Will Healy from Balluff today. Thank you so much for being here, sir. And for all of our listeners, thank you for taking time out of your busy schedule to listen to the Destiny of Manufacturing podcast. Again, we thank our sponsors, the Precision Metal Forming Association and the PMA's Educational Foundation, for helping us put this on. And everybody go out there and make it a great day. Thanks, everyone.
Thanks, Steve.